In this video we're going to talk about atoms and a little bit about the periodic table. So the periodic table has a lot of information that can be really helpful to us. And often you'll see it set up just like this, where each element is designated to a square. You have some information here. The symbol in the middle, it tells you what the element is. Mg stands for magnesium. This number above is the atomic number, and here it designates the number of protons in the atom. Magnesium has 12 protons, and this third number is the atomic mass. And magnesium has an atomic mass of 24.31. Now the atomic mass can be found based on the different numbers of isotopes. So almost all elements have different isotopes, which means that there's a different number of neutrons in the atoms. And these isotopes appear in different percentages. Magnesium, for example, has 3 isotopes. I'll just write them down here. We have the isotope of 23.985, and that comes in a percent abundance of 78.70. We also have the isotope 24.986, and that abundance is 10.13. And the third isotope is 25.983, and that comes in a 11.17%. So that means when you find magnesium, typically 78.70% will be the isotope 23.985, and so on with all of the isotopes, and that's just determined based on the number of neutrons. Now to get this value, it's an average of all 3 isotopes, including their percent abundance. And so to find that, the atomic mass you want to take the percent in the decimal form, and so you can do that a couple different ways. You can divide this value by 100, or just remembering that there's 2 zeros in 100, so you just move the decimal place 2 places to the left. And so it's the decimal value times by the isotope in AMUs, this value that we have here. And then you add the next isotope, the same formula. And so for magnesium, we can set it up this way. The atomic mass will be equal to 0.7870 times by 23.985. You add that to the next isotope. That's 0.1013 times by 24.986. And then the last isotope, in this case for magnesium, will be 0.1117 times by 25.983. Once you calculate that all out, you'll end up with the value of 24.309. And going to 4 significant figures, like what we have in our periodic table, the 0 will round up to 1, and we'll end up with 24.31 AMUs. And so that's how we can find the atomic mass based on the percent abundance of each isotope. Now this formula becomes really handy for a couple different reasons. We can find the atomic mass, or if we're given the atomic mass, we can find the percent abundance of a missing isotope, or even the mass of that percent of an isotope. And so, if you saw a problem that looked like this, dealing with chlorine, Cl, if you looked at the periodic table and knew that chlorine has an atomic mass of 35.45 AMU, you'd be able to start there. And so if we knew that one isotope is 34.97 and it is 75.77% abundant, we would know that the second isotope is 24.23% abundant. But let's say we didn't know what the mass was, if that was X. We could put this into our formula that we had. The atomic mass, the 35.45, is equal to the first value, the decimal form of the percent abundance, 7577, times by the atomic mass, 34.97. And we added that with the second isotope percent abundance, 2423, times by the value that we don't know, the atomic mass. We would be able to rearrange that. So based on this formula that we have, we can find the missing atomic mass. So if we first took care of this value and these parentheses, multiplied these two values together, that would give us 26.4967, and it goes on. But that would be our value there. We'd want to subtract each side by that value, and that would give us 8.953 is equal to this second value, the 0.2423 times our unknown. And based on that, we can divide each side by this 24 or 0.2423. Dividing that out, we would get a value that rounded to 4 significant figures would be equal to 36.97. And so that would be our atomic mass of the second isotope of chlorine. So you can see that this becomes a really important concept to be able to manipulate the formula that we have for atomic mass.